Hello everyone. Today we're going to look at scientific notation. We use scientific notation when we want to express numbers that are either really large or really small. Scientific notation looks like a times 10 to the b, where a is some number between 1 and 10. It can be 1, it cannot be 10, and b is any integer. If b is a positive number, then our scientific notation number is a very large number. It's bigger than 10. And if b is negative, then it's a small number. So it's smaller than 0.1. So we're going to first express the following in standard notation. So it's given to you as in scientific notation, 2.4 times 10 to the third. And we want to know, what does that actually mean? So remember, 10 to the third is 10 times 10 times 10. And the really nice thing about 10 to a power is that that power just shows you how many zeros. So 10 cubed is 1 followed by 3 zeros. So I'm multiplying 2.4 times 1,000. And again, the really nice thing about multiplying by powers of 10 is that all that's doing is moving the decimal. And the decimal is being moved however many zeros there are. And remember, how many zeros is the exponent. So I have 2.4, and I'm going to put a couple of zeros at the end. And I'm multiplying it by 1,000. I'm moving the decimal 3 places. I'm making it bigger. So I moved it 1, 2, 3 places. So 2.4 times 10 cubed is 2,400. If I have a number raised to a negative exponent, so negative 1.67 times 10 to the negative 3. Remember, negative means 1 over. So 10 to the negative 3 is 1 over 10 cubed, which is 1 over 1,000. So when I take a number like negative 1.67 and I divide it by 1,000, again, I'm moving the decimal, but now I'm making the number smaller. So I'm moving the decimal in the other direction to the left. So again, I'm going to put some zeros out front, and then 1.67. So here's where the decimal is. I'm going to move it 3 places to the left. So my new number is negative 0.00167. So in going from scientific to standard notation, I'm just moving the decimal, whatever the exponent is, places. And then if the exponent is positive, I'm moving it to the right because I'm making it bigger. And if the exponent's negative, I'm moving the decimal to the left because I'm making it smaller. So as another example, 8 times 10 to the 10th. So I'm going to take my 8 and then move the decimal 10 places to the right to make it a really, really big number. And I see that that is, again, 8 followed by 10 zeros in this case. So it's a very large number. And again, if you count them, you'll see that there's 3, 6, 9, 10 zeros that I added to the end of it. 2.465 times 10 to the negative 5th. So again, it's a negative exponent, so it's going to make the number smaller. So my answer is going to be 0.00002465. I'm going to move that decimal 5 places over. Notice that it's already between the 2 and the 4, so if I move it 1 spot, I've got 0.2465. I need to move it 4 more spots, which means I'm going to have 4 zeros before the after the decimal. So 0.00002465. Now we'll do a couple going backwards. So express the following in scientific notation. We've got 321 million. How can I put that into scientific notation? So I asked myself, is this a very big number or a very small number? It's a very big number. So I know that it's going to look like something times 10 to a positive exponent, because it's going to be a large number. and then I see where the decimal is to start off with, and it's right here. And then I have to figure out how many times do I have to move the decimal so that my new answer is somewhere between 1 and 10, again, not including 10. So if I move it over 3 times, I've got 321,000, that's too big. I move it another 3 times, I'm at 321, that's still too big. I move it over a 7th time, that's 32.1, still too big. So I move it over one more time, and I've got 3.21, a number that is very much between 1 and 10. And then I just count how many times did I move the decimal over. That was 8 times. So I have 3.21 times 10 to the 8th. B, 0.00045. This is a very small number, so I know it's going to be times 10 to a negative number. And again, I have to figure out how many times do I have to move the decimal until I get a number that's between 1 and 10. And if I notice, the number that I want is 4.5. So if I keep moving the decimal until I get in between the 4 and the 5, 4.5 is between 1 and 10. And then I count how many times I moved that over, and it was 4 times. So I get 4.5 times 10 to the negative 4th. C, I don't even know how to say this number. It's a very big number. But again, we start with the decimal over here if there isn't one. And then we ask ourselves, how many times do I need to move it over till I get to a number that's between 1 and 10? So 3, 6, 9, 12. I'm at 134. 13 gives me 13.4. 14 gives me 1.34. So 1.34, that's between 1 and 10, times 10 to the 14th power. And of course, I accidentally wrote a 2 there, so we'll pretend that that's a 4. For D, we have negative 0.2300. Again, it is a small number, so I know it's going to be times 10 to a negative power. And if I move the decimal over once, I now have 2.3 negative. And that is a number between 1 and 10. So that's the number that I want. That's my A, times 10 to the negative 1, because I only moved it once. So I get negative 2.3 times 10 to the negative 1. Now we're going to do a couple of applications of scientific notation. Using things in scientific notation can make multiplication and division of numbers a lot easier. So we're going to change the following numbers into scientific notation, then do the indicated operation. If I asked you to plug this into your calculator, there's a good chance that some of you would input it incorrectly. You'll have too many zeros or not enough zeros. It's really hard to make sure that you're putting in the right amount of zeros. So what we do instead is we change them both to scientific notation. The first one will be 3.2 times 10 to the 9th. The second one will be 4.5 times 10 to the negative 4th. And now if you notice, this is 4 numbers that we're multiplying. Multiplication's commutative and associative. I can multiply in any order that I want. So in particular, I'm going to put my 2 A's together and my 2 10 to the B's together. So I'm going to write this as 3.2 times 4.5 times 10 to the 9th times 10 to the negative 4th. 3.2 times 4.5 is something I can easily plug into the calculator. I get out 14.4. 10 to the 9th times 10 to the negative 4th is just rules of exponents. I have something to a power times that same thing to another power, so I add my exponents. 9 plus negative 4 is 5. So I have 14.4 times 10 to the 5th. However, this is not in scientific notation. 14.4 is not between 1 and 10. So to change that, I need to look at my 14.4 and say, well, what can I do to that decimal so that my number will be between 1 and 10? So I need to move it over to make it 1.44. Now I moved it over because it was a big number, and I moved it over once. So 14.4 is 1.44 times 10 to the first. And then I still have my 10 to the fifth. This, again, is the rules of exponents. I just add my exponents together. So I get 1.44 times 10 to the sixth. So let's try another one. We have 4,800,000 divided by 0.00000012. And again, I don't want to try to plug that into my calculator. It's too many zeros to keep track of. So instead, I'm going to put them both into scientific notation. The top becomes 4.8 times 10 to the sixth. The bottom becomes 1.2 times 10 to the negative sixth. Again, I'm going to split it up. I'm going to look at the division of my A's and the division of my 10 to the B's. 4.8 divided by 1.2 is 4. 10 to the sixth divided by 10 to the negative sixth. Remember, rules of exponents say I'm going to subtract the exponents. 6 minus negative 6 is 6 plus 6. So I get 4 times 10 to the 12th. Remember, a very large number divided by a very small number is an even bigger number. So this guy is much bigger than what I started off with. As our last example, we have two things that are being multiplied and then something that we're dividing by it. Again, that's a whole lot of zeros to keep track of, so we're going to put them into scientific notation first. So I want you to pause this first and put it into scientific notation on your own, and then unpause it and make sure you have the same numbers. Alright, so hopefully you paused it and you wrote it out. You should be getting 3.27 times 10 to the 16th, 2 times 10 to the negative 7th, and 3.4 times 10 to the 5th. When I break it apart, I have 3.27 times 2 divided by 3.4, so those are the A's I've collected. And then the 10 to the B's, 10 to the 16th times 10 to the negative 7th divided by 10 to the 5th. Again, this is something you can very easily plug into your calculator. You'll get 1.92. And then the 16 and the negative 7 you're going to add because they're being multiplied. And then you're going to subtract the 5 because you're dividing. So 16 minus 7 minus 5 will give us 4. So 1.92 times 10 to the 4th. Okay, so look through the book, read through the book, try out the homework problems, and let me know if you have any questions. Good luck.